Hello, my name is Annette and this is Chemistry at Glance. This is our second video in this series. We're still on organic equations and today we're gonna work on halogenation. Okay, so let's write the title. We're working on halogenation. So first of all, what is halogenation? Halogenation is adding a halogen, Cl minus, Br minus, R minus, these are the halogens, to an alkane. There are 3 steps in order to join the halogen with an alkane, and that's what we're going to do today. Our first step is the initiation. Initiation means the start of a reaction. During initiation, we change our halogens always go in pairs, and we change it into 2 chlorine radicals. In order to form a radical, we need to have a UV light. This is the condition needed for halogenation. So if you ever ask about the condition needed for halogenation, it's going to be the UV light. This is a homolytic bond fission. And what this means is that each chlorine gets 1 electron. Therefore, it forms a radical. Radical is a species with only 1 electron. So both chlorines get 1 electron, therefore they become radicals, and we need that radical for our next step. The next step is called the propagation. Propagation is basically a chain reaction. So I'm going to write 2 equations down and then we're going to talk about them. So here are the 2 equations. In this example, I used ethane. Ethane reacts with the chlorine radical, which we just formed, just one of them, and it forms a radical itself by losing 1 hydrogen. That 1 hydrogen bonds with our chlorine radical and forms hydrochloric acid. It's called a chain reaction because whatever we form here then goes down into the second reaction, and it's our radical reacting with chlorine, giving us our halogenoalkane. This is a halogenoalkane. As you can see, 1 hydrogen is replaced by chlorine. So halogenation means we're aiming to get this out. And we're left with 1 chlorine radical. This could go on and on and on. Again, our chlorine would react then with another ethane, would form another radical, and so on, so on. So, there are a couple of things that never change in this type of equation. So, we always react, whatever alkane we get, we always react it with a chlorine radical first. And we always form hydrochloric acid at the end. So, if we had C3H8, I'm going to write this for you, C3H8, we also would react it with a chlorine radical. Then what I would do is write the HCl first and see what's left. Whatever left is going to be on here. So we still have C3, we have H7, and this will be a radical. Then what you do is always take this radical which you just formed and put it into the next equation, like here. And always react it with chlorine too. Then next what you do, you put the chlorine radical down first, and then whatever left is going to be our compound. And it will go on and on and on. Therefore, propagation is called a chain reaction. And our last step is the termination. So when our chain reaction continues and continues and continues, we're going to have a lot of chlorines floating around, a lot of this radical floating around. We're going to have lots of radicals floating around. Termination is when two radicals meet. So it could either be our chlorine radical and this radical formed from our alkane, and we would get C2H5Cl, because this one has one electron, this one has one electron, they share it, they join together covalently and form a halogenoalkane, which is our aim. But we can also have a chlorine radical and a chlorine radical joining together to form chlorine, which we'll use again in equations, so that's useful. Furthermore, we can also have this situation going on. C4H10. So all of these could happen. Any two radicals can join together covalently during the termination step. But of course, our aim is to form a halogenoalkane. So that's what we want. So that's the aim of halogenation. There's also an overall equation I'm going to show you. So the overall equation is basically taking the alkane, reacting with the chlorine, because we need a chlorine in this reaction and we need the alkane in this reaction. And this would give us C2H5Cl, just like in this one, plus what's ever left. So in this example, it's HCl. So this is all you need to know about halogenation. You need to know the definitions of each of them. I created a blog post with all the definitions you need to know, so I will link that below for you to see. And I think that's all. I hope you liked this video. If you did, leave a thumbs up, subscribe, show your friends, and see you soon. Bye.